Hello learners, it's time for the lesson 3 which is on same distance. Let's get into the video. So this is a small reminder on the syllabus of the topic, which is your average speed being your lesson 1, distance and time reference is your lesson 2, questions based on same distance which is your lesson 3, the current lesson, problems based on trains being your lesson 4, questions based on boats and streams is your lesson 5, and questions based on races as your lesson 6. So the current lesson is on the questions based on same distance. That is when the distance covered is same, then comes under your lesson 3. Here is your componendo and dividendo theorem, which is a boon to save your time. So the questions based on same distance you can definitely solve using this componendo and dividendo theorem. And the theorem says the product of speed by distance will be equal to the distance of, the distance covered divided by the product of time, which is again equal to the difference in speed by difference in time. This can be solved using this strategy. See, this can be taken as A, this can be taken as B, and this can be taken as C. You can either compare A and C, or you can compare B and C, and that decision depends on the question. So from the question you can decide if it is going to be A and C being compared or B and C being compared. So you can compare and solve the question and derive to the answer very easily. Let's take some examples. So an increase, the first question is an increase in the speed of a car by 10 km per hour saves 30 minutes in a journey of 100 km. Find the initial speed of the car. So the regular strategy of solving this question is, let's say a car travels with some speed and it covers some distance with a specific time taken. So let's take it will be like this. See, as we know, speed is equal to distance by time taken. So you can take the distance as speed into time. I'm going to take the speed as S and the time as T. So S into T will be equal to. So you increase the speed by 10 km per hour. So now the speed becomes S plus 10 and the time taken is reduced by 30 minutes. So which is time T minus 30 or 1 by 2. So both these products will be equal to 100. So the regular method is that you can take 100 will be equal to S into T, multiply them in the place of S into T, you can substitute 100, derive to an equation and solve, which is again the longest ever strategy. So let's not go for this. So here is where we are going to use, see the question typically tells you that in both the cases the distance covered is only 100 kilometers. So it is the same distance question. So either I travel with the regular speed, which is S kilometers per hour, or I increase the speed by S plus 10. I increase the speed by 10 kilometers so that the new speed becomes S plus 10. My time taken is your usual time. So by increasing the speed, I reduce the time, or the time reduces by 30 minutes. However, the distance is 100 kilometers. So the distance is the same in both the cases. So here is where I use this componendo and dividendo theorem, and the theorem says the product of speed, because we know the speed is equal to distance by time taken, the product of speed by distance equal to the distance divided by the product of time will be equal to difference in speed by difference in time. And we are supposed to find the initial speed of the car. So since I'm supposed to find the initial speed of the car, I'm going to compare A and C. So A says the product of speed. So let's take S into S plus 10. So product of speed divided by distance. Distance we know, which is 100, will be equal to difference in speed, which is 10, divided by difference in time, which is 30 minutes. So 1 by 2 hours. So I have to take everything in hours, because here it is 100 kilometers and here it is S plus 10 kilometers per hour. So it's better I take in hours. So hours is half an hour. So 1 by 2 I'll take. So I'll put 1 here and multiply 2 on my numerator. So S into S plus 10 will be equal to 20 into 100, just 2000. Again, I don't go by the regular quadratic equation. So 2000 I have to factorize in such a way the product of two numbers should be equal to 2000 and the difference between them is 10. So I can either take 20 and 100, there's no way possible. 20, 100, and then I can go with 40 and 50. See, this I can convert as 40 and 50. So 40 is my regular speed, 50 is my S plus 10. So the initial speed of the car is 40, which is 40 kilometers per hour, and that is my answer. So moving to the next question. The question says if a student walks from his house to school at 5 kilometers per hour, he is late by 30 minutes. However, if he walks at 6 kilometers per hour, he is 5 minutes early. 5 minutes, no, he is late by only 5 minutes. Find the distance of his school from his office. So school to office, the distance is not going to change. So this is my school and this is my office, house. So however, from school to house, so let's take this as H. So from school to house, if I walk at 5 kilometer per hour, I'm late by 30 minutes. I'm late by 30 minutes. However, if I walk at 6 kilometer per hour, I'm late only by 5 minutes. Okay, I'm late only by 5 minutes. So since the distance between my house and school is just the same, I can definitely go with the complement dividend. And I'm supposed to find the distance of his school from his office. So I can again equate A and C. So the product of speed. So as I know, speed is distance by time. The product of speed by distance. Product of speed is 5 into 6. 5, 6 is 30 divided by distance, which is D, will be equal to difference in speed by difference in time. Your difference in speed is, see, it's a 5 kilometers per hour and 6 kilometers per hour. So my difference is just 1 divided by difference in time. Now, if in the first case I'm late by 30 minutes, and in the second case I'm late by only 5 minutes. So my difference is 25 minutes. So I'll take 25 by 60. So from here I can easily calculate that my distance is going to be 30 into 25 divided by 60. 30 into 25 by 60. So it's 225 by 2 gives me 12.5 kilometers, and that is the answer. So the distance from the office to school is just 12.5 kilometers. So we are using the complemento and dividendo to solve this. Moving towards the next question. So let me just solve this. By walking 3/4 of his usual speed, a man reaches his office 20 minutes later than usual. What is his usual time? So here is a challenge for you to try by the complemento and dividendo, but then I'm not going to use the complemento and dividendo here. So let us try by the other strategy, by walking 3/4 of the usual speed. So my new speed is 3/4 of the usual speed, and a man reaches 20 minutes later. So my new time is my usual time plus 20 minutes. So just for a change, we are trying with a different strategy. And my new speed is, since it is 3/4 of usual speed, my new time will just be the reciprocal of that, which is 4/3 of the usual time. So both are in terms of, both are new time only. So I can equate these two. So it very well says that 4/3 of the usual time will be equal to the usual time plus 20 minutes. So I can bring this usual time to the other side. 4/3 minus 1 gives me 1/3. So 1/3 of the usual time is equal to 20 minutes. So my usual time is 20 into 3, 60 minutes. So my usual time is just 60 minutes, and option A being my answer. You can also try using the complemento and dividendo and check. So again, with respect to the same distance, there are a lot of problems which will be shared for you to practice. So you can practice with the same concepts, the same strategy, and revert if you have any doubts. Thanks.